Hi, welcome back. In our last video we talked about our jib cylinder and we made a mathematical model in MathCAD to solve for it. Today we're going to make another model. This will be the static model of it, so we can calculate the force in the cylinder and the result reaction on the pin. As we go to MathCAD, you can see that we have two reaction forces, A, B, and then the force of the cylinder, which is the third one. We have our weight, our length, and two angles. We've already specified that theta is something we are going to start with, and delta is a variable that we calculated in the last one, and that's the angle between the cylinder and the beam. And we also calculated our forces here, and we came up with three simultaneous equations that we will now solve for. Let me make this a little bit bigger so everybody can see. Alright, we need to specify a couple things here. We need to specify that our weight equals 1,000 pounds force, just a generic number. If you want your jib to be stronger, you can make it bigger. And then we have a length here, and we need to figure that out. So let's go to SolidWorks. And we've got 53.5 inches. Okay. Something else we'll need to do, and I'll just do it off here to the side so that when you print it you don't see it. We're going to specify A, B, and C, or A, B in the force of the cylinder. Alright, and I specify all these every time to 1 pound. With an angle you want to get close to what you specify, but with the forces, really I've never had a problem with it. Plus, when I see a force of 1 pound, I know it's wrong. Okay, so let's get started here. So, first equation, 0. Sorry, we need to first get our solid block in there. And our first one is 0 pounds force. Always include the units and the Boolean equals. And that's going to be equal to A minus the force of the cylinder times the sine of our angle delta minus the weight of the load in this case times the sine of theta. Next equation. This will be equal to B plus the force of the cylinder times the cosine of delta minus the load times the cosine of theta. And our last equation, we got to include inch pounds or pounds inch. Alright, and that's the moment arm we calculated from last time. Minus the weight times the length times the cosine of theta. And that's just a small angle that we get there. Okay, so hopefully this worked well. Let's insert a matrix here. We want 3 rows and 1 column, and we're going to call it AB and force of the cylinder. And that is going to be equal to, let's drag it down here real quick. If I could type today, that'd be great. Okay, so we got a couple answers here. Some interesting things to note and think upon. Our force of the cylinder right here is the highest load, and we would expect that. We have basically a teeter-totter. We're pulling down here. We got to have a bigger load here and a smaller load here. We also see that B, which is mostly horizontal, or I'm sorry, mostly vertical, is a negative number, which we would expect. We have a force down, a force up, got to have a force down to hold it. And then we have A here, which we would expect to be in tension, so a positive number in this case, the way we've drawn it, and it is. So that's a good check. So what we're going to do here is calculate the reaction of the pin, and that's simply the sum of the squares, or A squared plus B squared here. So what this doesn't tell us is this the worst case? I don't know. It's something we're going to need to look at and look at a bunch of different angles. What I'm going to do is I'm going to stop the video here and calculate that out and come up with a table in a worst case position here. Okay, so I've made a small table here of different angles, and you can see here that as you get higher and higher, steeper and steeper with the jib, my force gets higher and higher. So I'm just going to come in here and just say use the negative 50-degree angle to size the pin. Alright, so I'm going to specify now our pin equals 1819 pounds force, and the force of the cylinder is equal to 2572. Alright, so that'll complete our lesson for today. Stay tuned next time when we actually size the pin. We'll use our Mohr circle equation to look at shear and normal stress and calculate that, and then give you some guidelines for pins as well. Appreciate you watching. Thank you and have a great day. Bye-bye.